we have the next talk by the same person.
That's because I registered SJ, who unfortunately couldn't make it. This is one. So I'll talk more about like the thing which I'm more like personally more deeper involved, like and not representing any organization or so. This is this olsrd project. Many of you know Freifunk, the Freifunk network. They use olsr, and some of the nodes also use the Batman protocol. So I wanted to briefly talk about. Come on, doesn't work here. I tried. Ah, here. Okay, thanks. I wanted to briefly talk about our progress with working on olsr, which has hopefully big impact on all the Freifunk-style networks in the world. olsr is RFC 3626. It's called olsr because it's open optimized link state routing. It was a diploma thesis by Andreas Tønnesen in Norway, and it became the de facto standard of mesh protocols on layer 3 in all of these Freifunk, Funkfeuer, Athens, wireless, etc. networks. Yeah? And since it was a diploma thesis, at some point you want the diploma thesis to be finished. So at some point you sort of become a bit sloppy with the code. It was a pain of the ass to maintain. There were only like patches all the time to it, and nobody really cleaned it up. What the effect was that it at some point became quite slow in the Freifunk networks. Now at some point people decided this is enough. Yeah? In Vienna, the Funkfeuer networks, people decided this is enough, we need to clean up. In Berlin, Elektra and a few others decided we need something new. So basically we have like the two branches now, evolution versus revolution. And our project is basically to clean up olsr and to make it very, well, performant. So this should be fish eye, not fishy. Okay. So what did we achieve in the last year? Main credits go to Hannes Gredler, Sven Ola-Tüke, and Bernd Petrovic. We achieved that the fish eye algorithm finally works. Nobody noticed that it didn't work. Yeah? For years. Yeah? So this works now. That means we have less packets going over the air. It means like there is no more airtime for the actual data to go over the air. Then the main issue was the CPU load was much too high. This was the CPU load before on the Funkfeuer network in Vienna with 400 nodes. It was around 60%. Now it's here, it's under 1%. Actually, I exaggerated that graph because so that you can still see a green line. The scalability was like that before. The Dijkstra calculations for shortest path calculations from A to the internet, from a node to the internet gateway, behaved like that before. Now it's here on the green line. So we are pretty sure that it actually scales now. Of course, there might be issues, but we'll clean them up on the way. So briefly, to give you a preview of what's going to happen in the next probably year. There is still a bug now, which we're working on it. It's NLQ, the one parameter sometimes turns to 0, means like the route switches. It's not necessary, it's a bug. So in case you notice something like that in your Freifunk network in Berlin, have a little bit of patience, please, and give us good bug reports. Then we also learned that in Berlin you have private IP spaces and you have a NAT somewhere, so your packets go out here that way. At some point the route might switch to a different gateway, to a different DSL line. That means your session is still stuck here. The packets want to come in here now. It doesn't work. So we'll have a solution for that, hopefully soon. And then we'll also have a new algorithm called CSN, which is basically will again clear up the air a bit, less packets. All the topology information, basically regularly now olsr sends out the whole topology graph of the whole network to the other nodes, right? This is like too much, so we can do much better by simply synchronizing only the differences. And then we are thinking about a new metric. It's called ETT. It's basically the well-known ETX metric divided by the bandwidth of the link. So we also recognize the bandwidth. And then something really sexy is going to probably come. I can't promise it 100% yet because it's like the hardest part, is multipath routing. Basically, what olsrd does now, it finds the best route in this dynamic mesh network. One single route. So all the packets, as long as this route is good, will go over that way. So what happens when all your neighbors have now nodes, and you could go around the buildings in different routes in parallel. You could send out different flows in parallel. So as soon as you have that, your network really grows. The bandwidth, the total bandwidth grows more or less, minus interference, with the number of nodes. Yeah, the more nodes, the more bandwidth. Okay, so this is like very nice target for us. Okay, this is it basically. So the future looks bright. Thanks a lot for listening.
Thanks. Then